Vanakkam. Now we are going to solve problem 3.1 from Digital Design by Moris Mano's 5th edition. The question is to simplify the following Boolean functions using 3 variable maps. So we are going to use K-map, Karnaugh map. And 4 problems are given here and we'll solve them one by one. Before going to solve these problems, we'll see what a K-map is. That too, here we have a 3 variable K-map. So let me explain about this 3 variable K-map first, then we'll dive into this first problem. In this problem, the variables are given as x, y and z. 2 power 3 input. So 8 number of min terms available. That means 8 input combinations are possible. Therefore, we have to represent this K-map with the help of 8 number of squares. Each square is called as a cell. So this is one cell, this is another cell, like that. Here you have 4 number of cells, here also you have 4 number of cells. So this is row 1, this is row 2. Then we have 4 columns. This is column 1, 2, 3, 4. Then you have to put a line like this. So this 3 variable K-map consists of 8 number of cells. Each cell corresponds to one min term. And here we represent this x variable. On this side we represent this y variable. And this first row is representing this x dash and second row is representing this x. On this side column wise, this yz takes the changes like this. First column represents y dash z dash. Second column represents y dash z. Third column represents yz. Fourth column represents yz dash. So if you look into this cells, the first cell corresponds to this x dash and this y dash z dash. So we get the combination or the midterms x dash y dash z dash. So if you look into the second cell, that corresponds to this x dash as well as this y dash z. Then this third cell, that corresponds to this x dash, similarly this y z. Then this fourth one, that corresponds to x dash and this y z dash. Then here this particular cell, that corresponds to x, and this column wise it is y dash z. Then this one, it is x, then y dash z. Then this one, it is x and this yz. And this corresponds to x, and here it is y z dash. Minterms can be represented using the binary. So here we are having the binary sequence. So it is for x dash, y dash, z dash, we have the value as 0, 0, 0. Then for this x dash, y dash, z minterm, we have the value 0, 0, 1. Okay. So if you have a prime like this, then it represents 0. If you have unprimed, then it represents the value 1. Okay, that is applicable for all the variables. Y dash means it is 0, y is 1. Z dash is 0, then Z represents 1 value. So now for this x dash y z, it is 0, 1, 1. Then for x dash y z dash, it is 0, 1, 0. Then for this x y dash z dash, it is 1, 0, 0. For this x y dash z, it is 1, 0, 1. For x y z, it is 1, 1, 1. And then for x y z dash, it is 1, 1, 0. And then if you look at this, if you see this binary value, it is 0, 0, 0, isn't it? Then the next value 0, 0, 1. So we have a 1 bit change at the last digit. Then from here, if it goes, it is 0, 1, 1. So already the 0, 0, 1 is there. Then this 0 changes. It is again a 1 bit change. Then when it goes from the 0, 1, 1 to 0, 1, 0, again we have the 1 bit change at this position. This 1 changes to 0. Then when you go from this 0, 1, 1 to 1, 1, 0, here also we have 1 bit change. This 0 changed to this 1. Then from this 110 to this 111, again you will be having a 1 bit change at this last digit. When it goes from this 111 to 101, again you will be having a 1 bit change at this center position alone. When it goes from this 101 to 100, again we have a change in this last bit position value. So this kind actually represents a gray code. So it is not an ordinary binary sequence. Instead, it is a gray code representation. So we have the decimal equivalent for this binary values inside the cells. That is 000 represents 000, 1 represents 1, 011 represents 3, 010 represents 2, and 100 represents 4. 101 represents 5, and this 111 represents 7, 110 represents. So while solving the problems, we would prefer to have only this decimal equivalent of the binary values, and this minterms expressions will not be entertained inside the cells. This is the format we are using to solve the problems, okay, while using the K-map. So now we'll see how to solve this. So here you have f of x comma y comma z, that is equal to sigma 0 comma 2 comma 4 comma 5. So you know that it is a function that consists of three variables x, y, z, and it is equal to the sigma represents the summation of the minterms 0 comma 2 comma 4 comma 5. So that's given in the problem. So whenever you get this problem, then for the corresponding minterms, that particular cell must be filled with the ones. So here you have a 1, and then for this 2, we have to fill this particular cell with the 1, and for this 4, that means you go for the fourth cell, fill it with the 1, and for the fifth cell, fill it with the 1. Okay, this is how we register ones into the corresponding cells, that means corresponding minterms. So the next step is to combine the ones which are available in the adjacent cells. So if you check this, these two ones are adjacent to each other, which are present in 0 and 4th cells. So we can combine them and we can number them as loop 1. Next, if you look at this, these two ones, that is the ones available in the cells 4 and 5, are adjacent to each other, so they can be combined. So we can name them as loop 2. Then when you see this one and this one are adjacent to each other, the 0th and 2nd cell are adjacent to each other, because only 1 bit change will be there. If you look here, this represents actually what? The 0 represents 000, and this second cell represents 010. In this we have the ones, right? So only 1 bit change is there, so they can be actually combined to form the loop, right? But when you look at the one at this 0, okay, that is available in two loops. This loop 1 consists of this 0th one, as well as this loop 3 is also consisting of this 0th cells 1. Okay, so it is actually a redundant one. So that particular loop 1 can be deleted, and we can now reconfigure them. So this is loop number 1. This can be taken as loop number 2, which consists of cells 0 and 2. This consists of cells 4 and 5. The next step is to write down the expression for this particular loops. For this loop 1, we are going to write the corresponding expression. So this 4th and 5th cells are covered using this particular variable x. So that means we are checking along this horizontal side. So that corresponds to x. On column wise, this 4th cell is covered by y dash z dash. So we have to write it. Then this 5th cell that is covered by this y dash z. So we have to write that too. Then if you have the change in variables, that means this z dash changed to z, right? That should be removed. And if you have this variables coming double times, that means it is repeating, that can also be removed. So finally you get the expression as x y dash. That is for this loop 1. Similarly we go for loop 2. So for loop 2, if you check horizontally, this row wise, these two ones are covering this x dash. So we have to write this x dash. Then vertically, this zeroth cell which has this one, right? So that covers this variables y dash is z dash. So we have to write it. Similarly, that loop consists of this one at this second cell. So vertically it is covered by this variables y is z dash. So we have to write it also. Y is z dash. Now we have the change in the variable y dash and y. Okay, so it has to be cancelled, and this z dash gets repeated. So one time it's enough. So we are removing this. So finally we get this expression for this loop 2 as x dash z dash. Okay, so then the next step and the final step is to combine this loop 1 expression and the loop 2 expression. So it is x y dash plus x dash z dash is the answer for us. This is the simplified expression. Okay, thank you. Hope you have understood this.